All right, so what we're gonna do is we're gonna show you some integration technique. I'm gonna ask you guys to think about this question before I start. So the integration was we're gonna talk about completed square. We're also gonna talk about this x plus 2, I think. Hold on a second. Let me see if it's right. X plus 2 over root of 4 minus x squared dx. Okay, so how do I integrate this function? I want you guys to think a little bit. You can try to execute a little bit if you for sure knowing what you're doing. If you don't think about it, if you don't know how to start, think about it a little bit more. Think about kind of plot in like what would be the best approach for this question. Antiderivative of x plus 2 over root of 4 minus x squared dx. What is a good path to do this integral? You guys can do this actually. It's not like something you're not able to accomplish. No, don't do that.
No? Don't do what?
That's gonna be way too much work. I won't give you anywhere. Trust me. No, don't rationalize. Rationalize is not a good path. Anybody can provide a good path to do this question? Yes. Yes. You can definitely split them because the bottom is one term. And the bottom is one term, they becomes two separate integral. Because this becomes, because bottom is one term, it's just one radical, right? Can I just do this and this? Of course, you need a dx on both of them. So yeah, you can do it separately. So you can still split them because now the term, even though is larger on the bottom, but it's still one term, it's still one radical. So good job, McKenna and Ashton. Right? Oh no, you cannot do that. You cannot split the bottom. The reason
I did 2 plus 2 plus x and 2 minus x.
yeah, then you cannot wait, hold on a second.
And then I squared the whole thing. So it was x plus 2 squared to the top.
I'm gonna look at it. I don't think you can do that. Let me try. Let me see.
2x.
Yeah. Wait. You change the top. You cannot change the top. You cannot square them. That mathematically from here to here it doesn't make sense. So what you can do is so let's just say if you put this, what can you do?
Oh my gosh, that's
Can you guys give me some?
Yeah, that's weird. But you square something. Let's just say you square. Let's say it's 4 over 3, right?
for this one.
You change the fraction itself because that becomes 16 over 9.
I get it, but at the same time, if you square 4 over root 3, it becomes 16 over 3, which is the same thing as 4 over 1 times 4 over 3.
How does that work? So let's say 4 over root 3?
Yes, 4 over root 3
Right? Square. So that's going to be 16 over 3, right?
Then another way to do it.
Times 4. You times this by 4.
Yeah, it's still this combination.
Yeah, but you take this
Oh, okay, no, the second one.
you change the fraction. You cannot change the fraction.
That's what, the right one is like 2. Okay, the first one is small. The second one might be right.
You times 3 times 4.
What happened to this? Arc sine of what?
So I don't get why you can't do this. And another way to write it is 3 is 3.
Nobody here is in that.
I made me wrong though.
Well, when you split it up, you can see yourself.
Correct. Because you're saying 4 over
Yeah.
change this fraction. Square something. That's it. You're saying say 3 squared is equal to 3. That doesn't make sense.
Am I talking to you?
Because you square something, it doesn't make they are the same as before. Like you square 4, you square 5 is 25. 25 is different than 5.
But how is it the same?
4 minus x.
Well, then if you root it up.
No. You're not trying to you square something because it's not here because if you have 1 third you're not changing the result. So now it's going to be 4 3. Now 4 3 is okay, you say this without square is equal to this. So you cannot square something because that doesn't make any sense. Now, if you split the bottom, if you split the bottom like this, then you can say that's different before. I think this side.
Yeah.
A plus c doesn't matter because you have 2 plus c's.
So you just, what do you do? No plus C?
Yeah, you could do plus c, but it's gonna be one general c because it's the initial condition. Okay, so what we're gonna do is we're gonna do u substitution here because you see there's 1 degree difference. You see 1 degree difference, so you cannot use arc sine the first one. You have to do u substitution the first one because u substitution here, then the du equal to negative 2x dx, which is the same as the same degree as this one. So be du over negative 2x equal to dx. So therefore, the first one is going to be x, this square root u, and this du over negative 2x. And as you see those x cancel out, that's going to be 1 over negative 2, u to the negative 1/2, and du. So obviously I can integrate that. That's going to give you integration of half, and this 2 over 1 times 1 over negative 2. So it's going to be negative 1. Now this one's going to be plus c, of course, but there's another one that's also plus c here. But this one I can say, oh, this one is going to be, you see that the top is 2, it's not x. It's not 1 degree difference. It's actually 2 degree difference. So u has to be x, and then du has to be dx. And u square has to be x squared, and a square has to be 4, a has to be 2. So therefore, it's going to be 2, it's going to be a squared minus u squared. And this is 2, this is going to be du. So that becomes 2 arc sine of u over a, which is u is x over 2 plus c. Now I hear you can join those two together. So that's going to be negative square root of 4 minus x squared and plus 2 arc sine of x over 2. So since they both have c, so you can put 1c at here. Because at the end, it matters is what's initial condition. If the initial condition is when x is equal to 3, y is equal to 1, then you plug it at the end to find out what the value of c. So that c is going to be combined joint forces, then you're going to have just only one c. You don't have to find separate c for separate initial condition. You only need one initial condition because start with the one integral. You just take those one integral, you add them together. That's it. Yes?
Like what degree difference do you use?
Do you see that usually 1 degree difference? I'll use u substitution because you take a du is going to be the same degree. Now, if there's 2 degree difference here, now this is fit into the format of a squared minus u squared and du on the top. Remember, on the top is du, on the bottom is u squared. So therefore, I can use arc sine. So this one is actually arc sine. This one's not arc sine because this one's just normal u substitutions. Does that make sense or no? Got it? Okay. So this is one of the questions that you had to be understanding what's going on. This is a good question, by the way. The next question is a little bit difficult. Next question is between 0 to 2. dx over x squared minus 2x plus 2. Now, today, this is something new. Now, this is a very popular question on BC exam. Not popular on AB exam because AB already have enough to test. So, BC is starting to move on to the more integral, more harder integral, where you have to do a different tricks. Now, especially for this one, is a very common question. It's always shown on FRQ actually. You see, multiple BC exam has this situation, the integration of this. There's a partial fractions, and this is completing the square is another one that's very popular. We're gonna talk about the easier version, which is this one, and we're gonna talk about a harder version of this. So this is definite integral. And you say, wait, how do I do this? What did I mention earlier? What did we do supposed to do? Complete the square. Do you guys remember how to complete the square? No. Okay. So complete the square is going to be 0 to 2 dx. And this is going to be x squared minus 2x. And we're going to give some spaces here. And we're going to say plus 2. And we give some spaces here. And you're like, wait, what does that mean? Well, for right now, those two spaces just 0, so it's still same thing, right? So can I do this? It's called complete square. Take the middle term divided by 2 and square. And some of you guys whisper, say, yeah, I remember that. That's a long time ago. Yeah, it's actually, you've done this last year. I didn't give you a test question, but example question, we've gone over very similar questions. But this time we're going to test them. So it's 1. So -1 squared is going to plus 1. So we're going to plus 1 here. Now, how do I do in the back to make it same as before? If you have plus 1 here, minus 1. So you got plus 1 minus 1. Essentially, they are the same. So we still want to have a net 0. It's like kind of chemistry, like combined ionic bond, right? Like sodium chloride, right? Sodium is plus 1, and Ethan's like, I don't remember chemistry. I just take it last year. Okay, so this is like a sodium. This is like kind of a chloride. Plus 1, minus 1. Wait, all you guys in AP Chem. AP Chem, AP Chem.
It's a miracle I passed it.
That's what I'm saying. That's what I'm saying.
McKenna, were you falling asleep in that class?
Yes.
And then Jenny falls asleep every time.
Jenny falls asleep?
Yeah, Jenny's behind me.
Fiona's asleep?
Yeah.
Okay, let me erase the sodium and chloride before you have PTSD. All right, so what happened is I'm gonna put a parenthesis on this two term, and parenthesis on this two terms, so that's gonna be dx. Now I'm gonna factor this. The easier way to factor, just use the -1. So it'll be x minus 1 squared plus 1 squared. Is that okay? Does that look like something like arc10? Okay, so now we can say, well, that looks like arc10. So u squared is equal to x plus 1, x minus 1 squared. U equal to x minus 1. And the a squared equal to 1, a is equal to 1. Du is equal to dx, which is perfect. So then, therefore, it's going to be du on the top because you can change the other one. And it's u squared plus a squared. Now, remember, change boundaries. So, remember this part? So, please change your boundary. The boundary is from 2 to 0. So, this one's going to be from 1 to 1, right? 1 to -1, sorry. So that's being -1 to 1. I change the boundary. I'm going to do everything in terms of u. Then that's going to be arc10. Good job. Arc10 of u, what is u? X minus 1, right? Over a, which is 1. And this is 1 over 1. And it's between 1 and -1. Whew.
Where did the plus 1 squared come
What are you talking about? Where's plus 1 squared? It was only minus 1 squared.
A squared, so 1 is a squared. If you change everything in terms of u, why did you go from 1 to -1?
Wait, it was 2 to 0 to 2 though.
Yeah, so like if you change it back to x plus 1.
So I plug in the 2 right here. So 2 minus 1 is 1. 0 minus 1 is -1. So it'd be -1 to 1.
Yes, but if
Oh, I said, yeah. You. My fault. You're right. Okay, so it'd be arc10 of 1 minus arc10 of -1. Now, arc10 of 1 is what? Pi over 4, good. Now, be careful with the second one. The second one is where a lot of students make mistake. Arc10 of -1. That's actually negative pi over 4. Thank you. So it's a negative pi over 4 because it's not the boundary. Yes, the boundary of inverse. So that's going to give you a pi over 2. So the answer is pi over 2. It's beautiful.
I'll consider that one next time.
You consider that?
No.
It's not that bad. Like, I assume all of them. You're welcome.
Dude, who does homework for you? Are you reading this?
How'd you guys pass AP Chem? How'd you guys pass AP Chem?
Homework. It's not as optional homework. Yeah, I'll do some.
I worked so hard for AP Chem. I worked so hard for AP Chem. Alright. Now this time it's gonna be a little bit harder than last time. This time it's gonna look like this. Oh, son of a pineapple. All right, so we have this function. This function look like this. And we want to find the area between 3 over 2. So this is some type of 3 over 2, and there's some type of 9 over 4 here. And we're going to find this area. But in order to find area, I must do what? Integrate. Good. So we're going to integrate this ugly ass function. And this is 3 over 2. And this is 9 over 4. And then we say, wait, how do I do this? How do I, right? So the hint is very, very easy giving. It's definitely not arc10. Because if arc10, then you have something plus something on the denominator. So what's that left with? Arcsine or arcsecant. But arcsecant usually have something outside. So there was something else here that you say, oh, okay, I don't know what to do here. So you can factor out x, but it doesn't, yeah, you can do that, but actually, can you? That's interesting. I don't know. You approach it that way. I'm gonna use my way. I think that's possible. I think it seems like it's a possibility. Okay, that seems like a possibility. But right here, might have the same answer actually. We can try it in a second if I have free time. But for me, I'm gonna just still apply and complete the square. This one. So in this case, I'm gonna change this to square root of. We're gonna give you some space actually in the front because we know it's something minus something. So this is a minus. Now I'm gonna factor out the negative sign for x squared, and this one's minus 3x, and there's some spaces right here. So there's some space right here, there's some space right here. What? We know we want to complete a square on the second part with the x squared minus 3x, and we had completed, but we want to make sure this is a negative sign because we have something minus something, right? But it's not, it's a number minus something. So shh. Give me a second. Let me finish this. Now I usually take this negative 3 divided by 2 and square. So that's equal to 9 over 4. So I am gonna add 9 over 4 here. But if I'm not at 9 over 4, am I really adding 9 over 4? Or am I subtracting 9 over 4? I'm actually subtracting because you see this negative sign is going to distribute here, right? So that means I have a net gain or net loss of 9 over 4. And I hate to mention chemistry. If you have net gain, you have net loss, you have a net gain in back. So this one has to be 9 over 4 here. And that's the integration from 3 over 2 and 9 over 4. And now, if when that happens, that's going to be square root of, this one's 3 over 2 squared, right? Is that okay? Minus x minus 3 over 2 squared. And that's equal to 9 over 4 and 3 over 2. Now, we're going to do u substitution. U equal to x minus 3 over 2, because u squared is equal, sorry, let me write down again. U squared equal to x minus 3 over 2 squared. U equal to x minus 3 over 2. And the du equal to dx, which is this dx. I forgot to write that. And also, I'm going to do change of boundary. So this one is 9 over 4 minus what? 3 over 2, which is 2 over 2, which is 3 over 4. And this is 0. So it's going to be integration from 0 to 3 over 4, summation of a squared minus u squared du, which is arc sine of u is going to be u over 3 over 2 between 3, 4 to 0. So what is arc sine of 3 over 4 divided by 3 over 2 minus arcsine of 0. So 3, 4 divided by 3 over 2. 3, 4 times 2 over 3. That's equal to 1/2, which is come out very nice number. So that's equal to pi over 6. And minus 0, so it's pi over 6. Which is that's a pretty cool question. Three over 4 over 3 over 2.
I think I'm gonna max out the level.
Is this okay? So this is a complete in the square. You can have some homework question about this. All right, we're gonna talk about one more question. Last one require a little bit of creativity. Okay, last one's a little bit hard, but it's also require a little bit creativity for you to solve this problem.
Hey, my God.
Where's my phone? Think about what you have to be. You don't need to complete a square here because you don't need to, because you don't have, you already have the 1 minus x squared. Now this one require you think a little bit. Think about how do you think 2 steps ahead. This one becomes a very easy question. Ashton's on the right track. Ashton's on the right track.
Then so like wait, but like oh wait it's not you so right wait no because that would be yeah.
Oh my God.
Why you say product rule? Somebody say product rule? There's no product rule or integral. How can you hit 2 birds with 1 stone?
If you derive art, wouldn't you get? Oh yes. So if you derive art cosine, you get negative 1 over root
Safa's cooking.
of 1 minus x squared, right? If you derive that.
Is boundary powers. Yeah, it should be negative. Yeah. It should be negative one. It should be negative u.
U equals to 1 over root of, no, 1 minus x squared.
I think I'm right.
Yeah, so that becomes c u root
Yes,
minus
I
x
thought it
squared
was
equals
No.
that cancels, right? Just because
I just wasn't sure.
yeah, then you just get what? You just get.
What did you get?
But if I cancel out, right? You get.
You had to be able to go all the way down.
Yeah.
What?
But I.
Well, no, dx equals. Wasn't it negative 2 right?
Oh, it is, yeah. So then you take the negative out.
So then the square root is what she's gonna get. Yeah, so you just
You.
yeah.
And then you take it out. Yeah.
Yeah, because then you flip it.
That's what I over.
She's not.
1.5.
So she's not here, but she's.
Yeah, Nelly, you can try to use the previous question with 3x. It didn't work out? It should work out the same.
It like was, but I just made it. Watch it. I'll do it.
Yeah. It's actually good thinking though.
Inverse.
Wait.
Yeah, so then negative part.
So there's some people already see that 2 steps ahead, because if I have u equal to cosine inverse of x, right? du is going to be negative dx over square root of 1 minus x squared. Does that make sense?
That's what I did.
I don't believe you.
So that's integration of negative u, right, du, and I'm going to plug in, this one is cosine inverse of square root 2 over 2, which is equal to what? Pi over 4. What's the cosine inverse of 0? Pi over 2? So this one is going to be pi over 4 to pi over 2. Now, if I take out, if I change a boundary, so that's going to be pi over 4 to pi over 2. And this one is going to be u du. Is that okay? And can it be u squared over 2 between pi over 2 minus pi over 4? So it'll be pi over 2 square over 2 minus pi over 4 square over 2, which is I can take out 1/2 in the front. This one's going to be pi square over 4 minus what? Pi square over 16. So I multiply this by 4 over 4. So this is equal to 1/2 3 pi square over 16.
I did it. I felt so smart, and it gave me a really nice answer, but I was just entirely wrong.
Entirely wrong?
Entirely wrong.
Oh my goodness.
I made an assumption in the assumption.
Oh my gosh.
But I had the right idea and the right. I had the right.
So you're just not.
I don't have to do it.
What around like that?
Well, just for me, bro. How do you love it?
Or if it looks like this, you know, grab the brain fry.
Yeah, so that's very funny. You guys are very technical. I'm shocked.